Welcome to FiberStar's webinar about how to use Citri-Fi citrus fiber to create high-quality meat alternative products. There will be two speakers today. The first speaker is me, Sheila McWilliams. I am the Regional Manager of U.S. Sales for FiberStar. The second speaker is Dr. Shuai Li, who is a Principal Scientist at FiberStar. I will start by covering the topics on our agenda. Then I will briefly introduce Citri-Fi citrus fiber and explain how different Citri-Fi products provide a variety of functionalities which benefit meat alternatives. After the review, I will hand it over to Dr. Shuai Li, who will cover different case studies. Then we'll wrap up with a summary and contact information. The webinar is muted to provide you with the highest audio quality, and you can ask a question at any time during the webinar. Just locate the question box, type in the question, and submit. There is an anonymous box when submitting your question if you would like to use this. Questions will be answered at the end of this webinar during the Q&A session. After the question and answers, there will be a brief survey available. Please fill this out to help us improve future webinars. Also, this webinar will be recorded and sent to you by email. Here are the topics we will cover today. The goal of the webinar is to teach you how to use Citri-Fi citrus fiber in a variety of meat alternative formats. This includes beef patties, hot dogs, sausages, meatballs, chicken patties, nuggets, and seafood products. First, let us review Citri-Fi product lines and their functionalities. Citri-Fi is an upcycled citrus fiber produced from byproduct of the citrus juicing industry. To create the fiber, we use a patented process, which is free from chemical modifications. Though a dietary fiber, this citrus fiber provides multiple functionalities, unlike some fortifying fibers on the market. It has fast hydration and high water holding capacity, in addition to emulsification properties. Citri-Fi is available in coarse and fine powders, which makes it very versatile in food products. Labeling options include citrus fiber, dried citrus pulp, or citrus flour, which all resonate well in natural and clean label markets. Citri-Fi is allergen-free and gluten-free. The 100 series is non-GMO project certified. And this citrus fiber has no E number, which is key to creating clean label products in regions like Europe. FiberStar offers several lines of citrus fiber. The 100 series holds a significant quantity of water and emulsifies. As a result, in meat substitutes, the emulsion creates juiciness and sizzling during cooking. Citri-Fi can bind up to 60% of the fat and oil. Because of this, the amount of saturated fat used in formulations can be reduced. Here is a demonstration of how Citri-Fi binds water and oil. During the hydration step, the fiber swells, increasing the surface area, allowing for oil binding. After shear mixing, a stable emulsion forms. Citri-Fi TX is one of FiberStar's most recent new ingredients. This texturizing citrus fiber is coarse, which helps add a meat-like texture to meat alternatives. It also absorbs water faster than texturized vegetable protein to help control the firmness without producing a gritty texture. This meat-like texture differentiates Citri-Fi TX from other conventional dietary fibers on the market. The TX helps to bind the proteins together, especially if it is used with the Citri-Fi 100 series. Citri-Fi is robust and stable under heated conditions such as cooking. As already mentioned, the 100 and TX lines are clean label. Now I'm going to hand this over to Dr. Shuai Li so he can share different case studies.
Thank you, Sheila. My name is Shuai Li, the principal scientist of FiberStar. Thank you all for joining our webinar today. Our target is to use our Citri-Fi to clean your label of the plant-based meat products. Before I start our case studies, I would like to briefly introduce the functionality of the ingredients that are used in our meat alternatives. First, our Citri-Fi 100 FG is an excellent natural emulsifier, which provides cold binding, juiciness, and emulsification properties. Second, Citri-Fi TX20 can help to improve the meaty texture and firmness. Citri-Fi TX20 has a large particle size, which is close to the size of TVP. It is a very unique texturized citrus fiber and the only commercialized product in the world. Both Citri-Fi 100 FG and the TX20 can synergistically work with methylcellulose in the meat alternatives, or work with other functional ingredients without methylcellulose. As a chemical modifier, methylcellulose is widely used in the plant-based meat to provide cold and hot binding, juiciness, sizzling, emulsification, and so on. So it is extremely challenging to produce a clean labeled MC-free product with a one-to-one replacement. Therefore, we propose use Citri-Fi to combine another thermogelling natural protein to make an MC-free product. All listed protein here can form gel to provide hot binding. However, each protein has its unique property. Potato protein is very easy to use to form a strong gel under heat. It is not compatible with solid fat like coconut or palm fat. It works well with most liquid oil. Canola protein forms firm gel as well when heated. We recommend use it along with gluten to balance the elasticity. Pea protein itself cannot form strong gel, but works very well with transglutaminase. In the following slides, I will introduce some case studies with Citri-Fi to combine different hot binders to make plant-based meat. Today, this webinar mainly discusses some different types of plant-based meat formulations with limited scientific results. If you are interested in any of these solutions, please feel free to contact us for detailed technical discussion. Now, I would like to start with 3 plant-based patty formulations. The first one is using Citri-Fi 100 FG TX20 to combine with the potato protein. The potato protein, Selenic 200, is sourced from Avivi. In this formula, we simplify the system without adding seasonings and flavors to highlight the impact of the functional ingredients. Here, we hydrate 17% TVP with hot water for 15 minutes. Next, we mix 1.2% Citri-Fi 100 FG and 5% potato protein into the oil. Then add water to form a uniform emulsion with a countertop blender. Later on, we add Citri-Fi TX20 into the emulsion and gently mix for additional 10 to 15 minutes. We don't recommend high shear at this step because we want to minimize the particle size reduction to maintain the texture of TX20. Next, we mix well the emulsion and hydrate TVP to form a patty in a 3-ounce round mold. The patty is recommended to store in the refrigerator. The patty will be cooked with a double-side grill under 350 Fahrenheit for 5 minutes, or until the internal temperature reaches 165 to 175 degrees Fahrenheit. If the patty is frozen, thaw out before cooking. In this formulation, Citri-Fi 100 FG is the key to provide cold binding because of its good water and oil binding ability to cohesive the hydrated TVP pieces and other ingredients. Citri-Fi 100 FG can form stable emulsion as well to retain the small oil droplets in the patty to improve the juiciness. Citri-Fi TX20 in this formulation can significantly improve the meaty texture and firmness of the patty. This formulation has optimized to balance the patty firmness and juiciness. Depends on your needs. It can be adjusted to be firmer or juicier. Note this formulation can use coconut or palm fat due to the off flavor that generates between potato protein and solid fat. The second formulation combines the Citri-Fi 100 FG, TX20, and the canola protein. Canola protein, purine G, is sourced from married functional foods. This formulation contains 2% Citri-Fi 100 FG, 4% TX20, and 3% canola protein. 4.5% gluten is used as well to balance the elasticity. The procedure is similar with the previous formulation. The only difference is at step 2. Citri-Fi 100 FG, canola protein, and gluten are mixed into the melt coconut oil. Coconut oil is compatible with canola protein, which helps for the seasoning and the juiciness. In this formulation, Citri-Fi 100 FG provides the cold binding and emulsification as well, and the TX20 is used to improve the meaty texture and firmness. We recently developed a new formulation by combining Citri-Fi TX20 and the pea protein, pizzazz, which is sourced from married functional foods as well. Pea protein can form good elastic gel with transglutaminase. In this formula, we incorporate color, flavor, and seasonings to produce a more complete product. In specific, we first hydrate the 4% Citri-Fi TX20 with TVP, color, and flavor in the KitchenAid blender. Next, we hydrate the pea protein and additional color for 20 minutes, then mix it with oil to form an emulsion. The transglutaminase is added at last step to combine with the emulsion and hydrate the TVP and the TX20. The patty formed and the cooking procedure is the same as the previous formulation. As an option, additional 5% solid fat can be added based on the total weight to improve the juiciness and the sizzling. Pea protein helps to make the patty elastic, but the overall patty lacks chewiness. So TX20 is very important here to bring meaty texture and firmness to the final product. In this slide, I display the patty pictures of above 3 MC-free solutions, including uncooked and cooked pictures. As a comparison, a control patty with 1.5% methylcellulose is included as well. Because of the Citri-Fi, the uncooked patty presents as good cold binding as the control, and the competitive firmness. The firmness of the patty is determined by testing the compression load at a depth of 10 millimeters using a texture analyzer. A knife edge probe is used to simulate people to eat a burger. With methylcellulose, the patty presents a firmness nearly 3,200 grams. It is very close to a commercial plant-based beef patty, Beyond Beef Meat. You can see all three of our prototypes present higher firmness than the control. Now let's move to a different meat type, hot dog. We developed two hot dog formulations. For the gum-free version, we combine 2% Citri-Fi 100 FG, 15% pea protein, and 3% gluten, and 1% transglutaminase to form the hot dog. This version may fit the European market well since konjac or carrageenan both have E numbers. In specific, pea protein is firstly hydrated well along with gluten and the natural color. Citri-Fi 100 FG is added into the oil along with flavor, salt, and sugar. Then combine both mixtures under sharing to form a dough. Transglutaminase is added at the latest. Later on, stuff the dough in a cellulose casing and store in the refrigerator overnight. We recommend to store overnight to let enzyme fully react with protein. The next day, the hot dog is steam cooked for 10 minutes, then peel the casing in the water to avoid skin adhesion. The final product can be refrigerated or frozen for storage. Another gluten-free version is replacing 3% gluten with 1% konjac and 1% carrageenan gum. The konjac and the carrageenan should be added at step 4 with Citri-Fi 100 FG and other dry ingredients. Here is the picture of the hot dogs, including the cross-section. The appearance of the two different versions is very similar, so we don't put comparison pictures here. In these formulations, Citri-Fi 100 FG is the key to balance the viscosity and improve cold binding of the hot dog. This will finally affect the compression strength and elasticity of the hot dog. We use the texture analyzer to measure the compression load at the fracture point, also the elasticity under the TPA mode. Here's the video example to show that the hot dog can be deformed over 40%, but recover to original shape. It indicates a very elastic hot dog. Moreover, the compression load and the maximum deformation ratio at the fracture point are tested. As a compression, the hot dogs without Citri-Fi 100 FG are tested as well. The compression strength of the gum-free hot dog is 4,125 grams with a max deformation of 61.3%. However, without Citri-Fi 100 FG, the compression load significantly reduces below 3,000 grams, and the max deformation reduces to 55.4%. Without Citri-Fi, the viscosity of the dough is too low and a small portion of water may separate out. That will affect the pea protein to form a strong gel. For the gluten-free version, the compression strength is 4,187 grams, a little higher than gum-free solution. Konjac and carrageenan forms a stronger gel than gluten, but less elastic than gluten. Therefore, the gluten-free version presents a relatively lower max deformation of 48%. However, if Citri-Fi 100 FG is not added in this formulation, both compression load and max deformation get reduced. Based on the combination of Citri-Fi TX20 and the pea protein, we also developed a sausage containing 2% TX20 and 7% pea protein. The mixing procedure is very similar to the patty, so I don't want to repeat it. After mixing, stuff the dough in the sausage casings and store overnight. The sausage is cooked in oven at 375 degrees Fahrenheit for 15 minutes. As an option, 3 to 5% solid fat can be added to improve juiciness and sizzling. An example of the cooked sausage is shown here. In this formula, Citri-Fi TX20 plays an important role to improve the meaty texture. We compared the firmness of the sausage with and without TX20. It is clear to see the firmness increases from about 2,500 grams to 3,500 grams. The sensory test also indicates much better meaty texture with only 2% TX20 added. Moreover, we can share sausage formulation to make meatball as well. After mixing all those ingredients, we form a 1.5 inches meatball around 25 grams and store overnight. The meatball is oven cooked for 10 minutes at 375 degrees Fahrenheit. Here, we display some cooked meatballs, including inside sections. Citri-Fi TX20 helps for the meaty texture and firmness for the meatball as well. Here is another example of a meatball formula that is developed by our distributor, IMCD China. In this formula, methyl cellulose is used along with 2.6% Citri-Fi TX20 and 0.9% Citri-Fi 200 Fg. The procedure is dry blend all the powders and then mixed with water and a soy sauce. Next, add the melted coconut oil to form a uniform emulsion. Texturized protein and the Citri-Fi TX20 are hydrated with hot water for 10 minutes, and then mix the vegetables with all other mixtures to form a uniform system and knead into balls. The meatballs are fry cooked later to reach inner temperature over 158 degrees Fahrenheit. In this formula, they found Citri-Fi TX can help with the co-binding and create meaty texture. Note, IMCD China used the Citri-Fi 200 Fg in this formula, which is a blend of Citri-Fi 100 Fg and guar gum, which provides enhanced viscosity and emulsification. IMCD Indonesia developed the chicken patty using 1.5% Citri-Fi 100 Fg to improve the emulsification, succulence, juiciness, and overall texture. In this formula, Citri-Fi 100 Fg works synergistically with other functional ingredients, including 1% methyl cellulose, 4% gluten, 0.75% potato starch, and 1.75% pea protein. In specific, 4 major steps are needed to make this chicken patty. First, hydrate TVP with double amounts of water and mix gluten, starch, pea protein, and seasonings in sequence. Second, mix methyl cellulose and Citri-Fi into oil and add this oil slurry in cold water under shirring to form a thick white paste. Third, combine hydrated protein and emulsion and store in the freezer for 30 minutes, then move to the chiller. The last step is to form the patty with 40 grams and store in the freezer for over 4 hours. In this slide, we present a nuggets formulation that is developed by Canal Brothers Philippines. 1.1% Citri-Fi 140 and 2% Citri-Fi TX20 are used along with methyl cellulose, waxy potato starch, guar gum, and different types of protein to make the plant-based nuggets. First step is to hydrate TWP and TVP. Second, plate chicken flavor in salt and mix all the dry ingredients into oil. Later, add water to form a uniform emulsion. The nuggets are formed in a mold and then frozen. Next, coat the frozen nuggets with breading and deep fry at 356 degrees Fahrenheit. In this formula, Citri-Fi TX is used to improve the meaty texture, and the Citri-Fi 140 is used to improve the binding and emulsification. Citri-Fi 140 has smaller particle size than 100 Fg. It is generally used to make a finer emulsion. The picture in this slide shows the cooked nuggets and the sauce. By the way, Citri-Fi 140 is used to make the displayed plant-based mayo and barbecue sauce. It is a good example of the application of Citri-Fi 140 as well. Here is another methyl cellulose-free formula to make plant-based nuggets. 2.8% Citri-Fi 100 Fg is used to form emulsion in the meat phase along with texturized gluten, powdered gluten, and guar gum. Batter coating is produced separately. In the meat phase, the texturized gluten is hydrated with hot water under initial moderate mixing and additional 10 minutes without stirring. Then dry blend all the dry ingredients and coat in the hydrated gluten. After that, slowly add the rest of water under moderate mixing to form a uniform dough. At last, form around 10-gram nugget mold. For the batter, first blend all the dry ingredients, then add water under stirring and add vinegar just prior to par frying. Next, coat nugget with around 15% batter. Later on, par fry at 356 degrees Fahrenheit for 1.5 minutes and freeze as soon as possible. At the end, deep fry at 365 degrees Fahrenheit for 3.5 minutes before serving. The last formula I want to introduce is plant-based fish. That is developed by IMCD Indonesia. Citri-Fi 100 series typically use less than 2% in the meat alternatives. In this formula, only 0.2% is used in the formula to improve the emulsification, succulence, and overall texture. In specific, we firstly hydrate the high moisture meat analog and the TVP with 100 grams of 0.1% sodium gluconate solution for 30 minutes, then squeeze out the water. Next, we cut the TVP into thick slices and chop it with high moisture meat analog until fish-like texture. After then, dry mix hydrated protein with pea fiber and stir fry with 4% oil for 10 minutes at 212 degrees Fahrenheit. Dilute the Citri-Fi with water first, then mix with sugar, salt, stevia, color, yeast, and remaining sodium gluconate for cooking 25 minutes. Later on, mix well DHA fish oil, flavor, vitamins, and oil for 1 minute to make a uniform system. Then store in refrigerator. Now I will hand over to Sheila. Thank you.
So let's recap. First off, Fibers Star offers multiple Citri-Fi products that provide different functionalities. The 100 line provides the high water holding and emulsification properties. The TX line produces a meat-like texture and helps with the firmness. Citri-Fi can be used with methyl cellulose in formulations, or this citrus fiber can be used in conjunction with other natural ingredients like canola, pea, or potato protein to create clean label or methyl cellulose free meat substitutes. The Citri-Fi 100 series can be used alone or along with the Citri-Fi TX to create the targeted meat alternative texture. The Citri-Fi line can be used to improve texture and juiciness in different plant-based formats, including patties, hot dogs, sausages and meatballs, chicken patties, nuggets, and plant-based fish. Thank you for attending this webinar, and we plan to host a follow-up webinar that will go into more formulation detail and troubleshooting tips when creating clean label meat alternative products. So please stay tuned for our future date and time. As mentioned, this webinar was recorded and will be sent to you via an e-blast. And please take the survey that follows the question and answer session. If you need additional information, please visit our website at fiberstaringredients.com, and you will find usage tables and video tutorials on how to use Citri-Fi in various food applications. And you can also request samples. Listed here are some of FiberStar's team members. Please contact one of us if you would like more information. So now let's move on to the Q&A session, and the moderator will begin asking questions to the team.
Hello there. So we have a couple questions that popped up during the webinar. So let's start with the first one. So the first question is, I'd like to know what is the aim and role of the transglutaminase, please?
Transglutaminase is the enzyme that provides a protein cross-linking. So it is gonna generally used for making that pea protein-based formulation. So it will help all the pea protein to form a strong gel during the overall formulation.
Okay. The second question is, why the addition of the 100 FG to improve the compressive strength of hot dog? Is the 100 FG function similar to a gum?
I think the Citri-Fi 100 FG is very good for oil and the water binding. So it will form a high viscosity overall dough with the Citri-Fi 100 FG. It have some additional gelling properties as well, but not as good as those gum to form that like jelly gel. Here, the Citri-Fi 100 FG functions well because it will balance all the water oil binding within the overall system. So it will absorbs all the pieces together. So it's not exactly like the gum, how the gum looks like.
Okay, great. Thank you. Next question is, how long does it take for the different types of Citri-Fi to hydrate?
Citri-Fi is hydrated very fast. Typically, within 5 minutes, it would be good enough, no matter what is cold water, hot water. And ideally, we just leave it for 10 minutes to let it fully hydrate, so it will work very well.
Okay. I have another question. At what level of shear helps to make stable emulsions with Citri-Fi?
Depends on the applications. We are recommending different type of blending technology. Typically, we're using a high shear to make a very nice emulsion, for example, countertop blender or the IKA type dispenser to making a very fine and small oil droplets based emulsion. However, you can also use like a KitchenAid based to have a kind of a rough emulsion as well. Depends on the Citri-Fi ratio. So it's quite flexible But definitely, if you have a high shear, it really helps to make the very stable emulsion, especially like homogenizer will make the very, very stable emulsion and the thick emulsion as well.
Great. I have another question. So you mentioned the Citri-Fi 100 helps with the fat and oil binding, and as well as the water binding. With the TX, in addition to texturizing, does it also bind oil?
Yes, it is the same product but different in the particle size. However, the Citri-Fi TX20 compare our regular Citri-Fi 100 series product. It is more benefits to have that structures to provide a meaty texture. But itself, it's still a citrus fiber. It still have the binding benefits, but not as good as the Citri-Fi 100 FG. That's the reason we usually recommending to combine two different types of Citri-Fi product to working the meat alternative formulation.
Okay, great. So do the solutions presented work with other types of texturized vegetable protein?
It is a little bit different. I think for most of the texturized protein, if you give enough water and hydrated it, the texturized protein may become mushy when you have the final product. However, Citri-Fi TX20 is kind of a fiber-based material, have a strong network. After hydration, when you mix the TX20 into the either patty or different type of plant-based meat, it will still maintain that structure. So when you chew, and you will feel that bouncy texture within the either patty or sausage, give you a much better meaty texture.
Okay, great. I have another question. There's two parts to it. How long does it take for the transglutaminase to form cross-linking of pea protein? And the second question is, do the enzyme cross-linking process require a certain temperature?
Typically, enzymes do have limitations for the temperature and like pH, whatever. The transglutaminase is relatively flexible. The ideal temperature will be 50 to 55 degrees Celsius for 1 to 2 hours. But we usually leave it a longer time at cold, so it still works. So unless the temperature not higher over 55, the enzyme is alive, it will keep working. So in our formulation, we recommend overnight to make the enzyme fully reacted with the pea protein. Or if you want it to leave in the room temperature, I would recommend at least 4 to 6 hours. Or if you can run a little bit higher temperature, like 50, it's probably gonna be quick. For 1 to 2 hours is good enough.
Okay, great.
Yep.
I have one more question. So if some of the formulations recommended both the TX and the TX20 and the Citri-Fi 100, but is it also possible to use the 100 alone?
Yes, that's the two different products. Citri-Fi 100 FG, as I mentioned, is usually used to improve the viscosity, emulsification, juiciness, and cold binding. So for example, in the hot dogs, we don't want that texture, meaty texture, because we want a very smooth overall dough and a smooth surface. So we can use the Citri-Fi 100 FG only in that hot dog formulation. And the Citri-Fi TX20 is the same. It's kind of help to improve the meaty texture. In some of our formulation, we're only using Citri-Fi TX. It's clearly to see that the texture improvement. So it's a two different type of product that you can use it together. That will give you the best options to balance the overall system. But if you can always use only one of the product, with and without methylcellulose, and with other functional ingredients, hydrochlorides, it's very good to synergistically work with other ingredients as well.
Okay, great. Are there other types of meat alternatives you'll be working on in the future?
Yes, we're thinking to develop more formulations and try to incorporate Citri-Fi into different types of meat type. Yeah, definitely, that's our plan.
And I have one last question. It says, do you have team members available to work on site for formulating meat alternatives?
I'm sorry, I missed this question. Can you repeat it?
Oh, sorry. The question was, do you have team members that are available to work on site when formulating meat alternatives at labs?
I misunderstood this question. The T number, what does T number?
Oh, I think they're asking if there's people available to, like, technical service available.
Oh, team member. I'm sorry.
Yes,
okay.
Yeah,
yes, definitely. We're providing the technical support for. We can schedule call. We can on-site help for some projects. We'll keep doing that. Yes.
Okay, great. So that concludes the Q&A. I just want to remind everybody that if you want to contact us, you have information here. Also, there is a survey at the end of this webinar. We appreciate it if you can fill it out. It helps us improve our webinars in the future. And we hope that everybody has a great day or night. Thank you.